in your calculator. And his fingers were so big, when he would go to hit 2, he would hit like 2, 5, 7, and 9. And then he'd hit plus. And then when he'd go to hit 3, he'd hit like 3, 8, and 12. And so then his calculator would spit the answer of 4,387, and that's what he would write down. Okay? Okay? What's the moral to that story, do you think? Know what the heck 2 plus 5 is, because you're counting on your calculator. If you don't, 2 plus 3 is because if you count on your calculator and you don't, and it spits some stupid thing at you, you need to know. There's certain things that you need to know. Okay? Okay. Now that last quiz, the quiz I'm getting ready to pass back to you.
I didn't even think about it.
The quiz, then I didn't think about it either. It's just, it's natural reaction. I swear I don't even think about it. So, on that last quiz, this was not on it. But everyone in here should know how to graph that. You're like, I don't know how. Do you not know how to graph that?
It's the shooting star.
It's like...
Okay, you call it a shooting star. That's fine. It's really a sideways parabola. Half of the sideways parabola, isn't it?
Yes.
Okay? Because you can square both sides and then it'd be x equals y squared. Okay? But that's the graph of that. Okay? So, when you have this on your exam, which was on the quiz, you should know what that graph looks like. So when you're plugging things in to your calculator and you get these stupid answers, you're like, well, something's going on here. You need to know that this graph looks like this right here, so that you don't say 2 plus 3 is equal to 4,387. You see what I'm saying? Huh? Yeah, you see what I'm saying? Now, sometimes you're going to get graphs that, man, you have no clue. I mean, if this is the graph e to the negative x squared plus 5 over x minus 3, no one knows what that graph looks like. Okay? You have to count on the calculator, and whatever the calculator spits at you, you have to say, wow, that's got to be it. But this guy right here, you don't need to be relying on the calculator to do it. Now, you want to put it in and verify some stuff, but you need to be like, I know what that guy looks like. And if I need to get the area of that from there to there, I know where I'm integrating from. I'm not going to integrate from 0. Because if I integrate from 0, where's that graph at x equals 0? No. It does not exist, and so you get an error on your calculator, and you don't have to say, Mr. Gould, my calculator's broken. Because your calculator's not broken. What's broken? You. Okay? Okay? Alright, now I'm going to pass these back. And we're going to go over them. We're going to have a quiz. We're going to have a test on this next Thursday. And the people who have 1s, 2s, and 3s, or 0s, 1s, 2s, and 3s, need to step it up. The people who have 6, and it was out of 13, actually. So, yeah, and there was one person that got all the bonus points. No one in this class. Okay, it's the 10th grader that we have in the 4th period class. Skylar, the pitcher.
He's smart.
He's pretty smart. Okay, Kyle Wagner. Jack Rush. JJ.
I'll get it.
Okay. And Wade, she's not here today, that's fine. Caleb. Woodsy.
I thought I'd get credit for my work.
Trinity. Slinky. Silky. Blanco.
Oh, hoorah.
Hey, dog. Saw your brother yesterday. Hey, dog.
Yep. No, that's not
Abbott.
Tyler Steve.
Who?
Tyler Peabody.
Oh. I remember his name from football, but I don't know him. Spitz.
Bro.
O'Donnell.
I miss that dude.
Jay Murr.
Everybody doesn't like me.
Vin Sid.
All I'm saying is...
And I tried to put some bonus on this so you start off with a good grade for the semester,
No,
right?
absolutely.
Well, that didn't work out. So Ryan T,
Because that's what sucks.
Young,
That's me.
Cool, Sapwood, Ryan D, 5, Jenai, Christian,
No, you did good. You got a 7. I got a 30. No, it's not a 10. It's out.
Ollie, Bardo, let's get to Bardo. How come Cool's not going to get in? Yeah, exactly. That threw everybody off. Voice out.
Watch me start.
I was not.
Margie's not here. Dan the man has a plan. Maggie May. Your middle name May.
After I did these,
Agnes.
I really thought I did this wrong.
Alright, well at least it's not it. That would not be good.
Pointer.
I felt so bad. What? My quiz? Oh yeah, I got a 1. I didn't have a calculator. I'm not stupid.
I mean, I don't quite understand what that means. Because that's complicated. Yeah, you probably would have done really well if you just knew what another problem was back.
I was so mad.
Only someone would have thought that.
How did you even get a point? Yeah, I know. I got.
Hey, J-Mar, would you pull that down for me up here? So I was on the interview committee yesterday.
Yeah?
Yep.
Yeah.
How'd that go?
I always.
Good. We had people from all over. Yeah. Guy from Arkansas.
Arkansas?
Yeah.
Who'd you feel the best about?
Everything.
Who did you feel the best about?
Can't tell you.
After class. It doesn't affect me.
We'll know though come Friday.
Friday? Like this Friday or next Friday?
This Friday. Well, I mean they meet with Miss Beale on Friday. So.
Oh, that's what's up.
Did they announce it?
Well, I don't know why.
She may take the whole weekend to decide. So, but she won't take more than a weekend. My guess is she'll decide by the end of the day.
We're gonna go over homework problems.
No.
It doesn't affect us.
If we have time, but I don't think we have time. I'm gonna go over that quiz because I'm not. Yeah. I mean, the only person that doesn't need to see me go over the quiz is Skyler, and he's not here, so.
It's okay. I figured these are the numbers. I know I always forget because I was always going on and I was
Is that thing on? Yes.
I was like, that makes sense. Just add that whenever you're figuring it out. Except for 2. I did not want to do these. So I didn't even really want that. Oh, I don't need that one. I'm like,
I did that right.
I just want
Are you still low for that?
What's wrong with this thing?
last year, math was
Yeah.
my favorite subject.
No, I love math. I got the high.
No, I'm on this year. It's hard.
You can have that. You can have that.
Okay. It doesn't work. It's screaming okay. Okay.
First one.
Now,
First one of the year.
right here. Oh, it is. Okay. Yeah. Okay, here we go. So it says find the area of R. Okay. Like I said on the board, you kind of need to know what the graph of the square root of x minus 1 looks like. There's what it looks like, and you also need to know what the graph of x equal 10 looks like. Okay? And so for part A, when they ask us to find the area, it should be really simple. I should integrate from where to where? 1 to 10 of the square root of x minus 1. And you can plug this into your calculator, but there's no need in that because it's jumped to the 1/2 power. So now it's x minus 1 to the 3/2 power over 3/2 evaluated from 1 to 10. Okay? Yes?
Yes.
Okay? And so when I plug in 10, well, I get 2/3. When I plug in 10, 10 minus 1 is 9 to the 3/2. Yes? And then when I plug in 1, I get 0, don't I? Who knows what 9 to the 3/2 is? 2 times 27 over 3, which is 9, which is 18. Yes? Now, was that hard?
No.
That's not hard, is it? Okay? Now, tell me when I get to something difficult here, please. Okay?
I feel like that's a question we shouldn't answer.
Now, part B. No, I mean, maybe we are going to get to something difficult before it's all said and done. But if you don't know what that graph looks, well, I mean, no, it's on calculator active, so you really didn't even know. You need to have a tiny clue so that you can set, so that you know it doesn't touch at 0. Because if you put in the wrong window, it looks like it may touch at 0. I don't know how you. But anyway, I don't know how you say 2 plus 3 is 4,387. Anyway, part B. Find the volume of the solid generated when R is whooped about the horizontal line y equals 3. Let's figure out what this point is. What is that point there? This point right up here.
10,
It's 10, comma 3. So when I look at the line y equals 3, it goes through right there, doesn't it? Yes? And so I'm going to take this guy and whoop it about that line. Should I be using dx rectangles or dy rectangles? I should be using dx rectangles, right? And that's what you say to yourself. You say, Yosef, do I use dx or dy? Then what do you say next? Disc or washers? And you say, is that a washer or a disc? It's a washer. Since I've got dx, we know we're going from 1 to 10 again, yes?
Yeah.
Okay? The outer radius starts here and goes to here, and it stays the same, doesn't it? That's big R. So it's the function that is furthest away from the axis of rotation. Could you go back and look at your notes and see where it says big R says is the function that is furthest away from the axis of rotation? Okay? So how long is big R? 3. Big R squared. Yes? Minus how long is little r? And don't forget it's going to be squared. Well, it goes from here to here, doesn't it? There's little r. You see where I drew that? Were you watching closely? Oh, no. Undid everything. Okay? So there is big R going from there up to there. And little r goes from there to there. So tell me how long little r is. Huh? Yeah, or 3 minus the root of x minus 1. Either or, right? Squared. Then, this, you don't want to do this by hand. That's why it was a calculator active problem. Notice, I have not broken out a calculator yet. But now is when I break out the calculator. Not to graph the square root of x minus 1. I break out the calculator to do this integral for me, so I do not have to waste the time doing that. And when I bust out the calculator pukes the number at me, 212.058. And then you move on. You do not use your calculator to do 2 plus 3. Use your calculator to do pi times the integral up from 1 to 10 of 3 squared minus parentheses 3 minus the square root of x minus 1 squared. You follow me? Okay? Part C. Find the volume generated when R is whooped about the vertical line x equals 10. So I'm going to take this guy and I'm going to whoop it around this line right here. We need to be perpendicular to our axis of rotation. And when I whip it around that line, am I going to use dx or am I going to use dy rectangles? Don't forget your pi. dy. Okay? Now, where does y go to and from in that picture? 0 to 3. So far, so good. Then you say to yourself, Yosef, is this a disc or a washer? I had a student named Yosef one time.
Good. Did you say that one?
Well, I got taught Rob. But I said, do you say Yosef? I always say Yosef. So anyways, it's a disc, okay? How long is the radius of my disc? What is it? Well, first of all, I've got to say y is equal to the square root of x minus 1. We need to solve it, don't we?
Yep.
And we get y squared plus 1 is equal to x. Yes? Okay? Now, realize that my radius is going from here to here. Yes? If I give you a point over here at 9, and I give you a point back here at 3, how long, what's the distance between those 2 points? How do you get that? The one on the right minus the one on the left. Okay? How long is this radius if I do the one on the right minus the one on the left?
10 minus the function.
10 minus the function. Oh my God. 10 minus the function, and the function I think was y squared plus 1. So it's pi r squared, right? Are you guys with me? Yes? And then you plug this in your Ladora, and your calculator pukes at you 407.150. You see when you use your calculator? Yes? Okay? That is one of the... so, wow, you come in with a sling on Monday, on Tuesday, and on Thursday you come in with a little hand guard.
Yeah.
So then next week you're going to come in with nothing, huh?
No, in 4 weeks I'll come in.
Okay. Wednesday you went to the doctor or something?
Yeah, and...
Took the sling off.
Yeah, because I only have the sling temporarily because that was just right after the surgery.
Surgery?
Yeah.
Dang.
Yeah, I got a metal plate and 7 screws put in.
Oh yeah? I've got my metal plate down there for my arm down there in my other classroom. I'll let you look at it so you know what you got in your arm.
Okay.
Why'd they take it out?
Huh?
Why'd they take it out?
Who wants a bunch of metal in their
Metal
arm?
detector.
He said I remember.
Magneto.
That's fair.
Yeah, Magneto comes after me. It's cool now.
I was
Except for that screw I got in my thumb, see it?
I was so close. I forgot my square and I just put it
He's
back.
taking your thumb.
I was
He was like, no.
And then this one, I didn't know they had.
Okay, here we go. Here we go. Get ready for a big whistle.
Wait. This is
What?
B was B a washer or a disc? Or
B was a washer,
It was flush.
Okay.
and C was a disc, because it was flush. Okay? Now, let's look at problem 2. A tank contains 125 gallons of heating oil at time t equals 0. During the interval from 0 to 12, heating oil is pumped into the tank at this rate. During the same interval, heating oil is removed from the tank at this rate. How many gallons of heating oil are pumped into the tank on the interval from 0 to 12? Well, you just take this and you integrate from 0 to 12, what am I going to integrate? H of t. Is it okay to write H of t? Do I have to write the whole thing out? You can write H of t. Okay? And then you plug it into your calculator, and your calculator pukes at you 70.75571.
What?
5, 5.
It was hard.
8.
Okay?
4,380.
Part B. Is the level of heating oil in the tank rising or falling at time t equals 6? Give a reason for your answer. Okay? Do you think if I give a reason for my answer is, oh, I just think it's rising? Is that good enough? No.
Yeah.
If I say it's rising because more is being pumped in than being taken out, is that a good enough reason? No. Why not? Of course, if more's pumped in than taken out, it's rising, right? It's like, what kind of idiot's going to say it's rising because more's being pumped out than going in? That's like dirt, right? I mean, really, you could ask a kindergartner, if I pour water into this bottle, is it going up or going down? And they'd be like, it's going up. You don't have to know any calc. They want me to give, when they say give a reason for your answer, they want some kind of a calculus answer, right? Some numbers or something, not because more's going in than it's coming out, right? Yes?
Yes.
Okay? So, I need to see how much is going in. How do I figure out how much is going in? H of 6. And that gives you 5.395. Okay? I need to see how much is going out. How do I see how much is going out? R of 6. And you plug that in, it's 8.319. Now, some people actually had numbers that were close to these, but they rounded to 2 decimal places. I don't think there's anybody in here. Maybe it was. They rounded to 2 decimal places or 1 decimal place. Okay, and you're like, oh, I didn't know we went to 3 decimal places. Well, sometime before May, remember, we go to 3 decimal places. Okay? You may say, I'm going to wait until like May the 1st to remember that. Okay, that's fine. Just before May, remember that. I don't know, second week of May, I think. I think you got the seniors' last day happens, and then you have to come back and take the exam.
Awesome. Oh my God. Oh, nice.
That's what they get for letting you guys out so early. That too. Okay, now, so is it rising or falling? Falling.
Because
R of 6 is greater than H of 6. Well, since you got 6's there, it's obvious. But if you wrote that, it'd be fine. Okay? Does everybody see that? And poor Ollie, that's the only point he missed. So we almost had a perfect grade in here. That tiny little area. Miss Collins made 100. She's kind of not bad.
You said it's out of 13, though.
Well, because I didn't sign up.
I didn't do it.
So, okay, part C. Part C. How many gallons of heating oil are in the tank at time t equal 12? How am I going to figure that out? Huh? Plus 125. I say, I come up with this function that tells you how much is in the tank. It's 125 plus the integral from 0 to t of h minus r. Yes? What kind of formula is that right there? Future value. Yes? The future value rears its ugly head once again. Okay? And so you want to know how, oh, I shouldn't say H, I should call it A. Amount. So the amount at 12 is equal to 125 plus the integral from 0 to 12 of h minus r. You plug this into your Ladora, and your Ladora pukes at you 122.026. Like OMG.
I just forgot to add the word.
Yeah,
When you say you just,
I know it's
that's big.
Oh my God.
Okay?
That's when you
Down. Part D. Okay? Yeah, it's like when the dogs get out. You're like, I just forgot to close one gate. Okay? Part D. Part D. At what time T is the volume in the heating oil the least? Yes, sir. I don't know, 1? Yeah. Because I'm just trying to make it as close to 10 as possible and give you guys a few extra bonus points instead of making it out of 20. Okay? If you made it out of 20, then you're really behind the 8 ball. Right, what's that mean, behind the 8 ball?
Sounds bad.
Hey, Mom, is that intersection
Yeah.
points or you find zeros?
See, back in our day, people played pool. These guys, they don't even know what the game of pool is. They think pool's something you swing. They think it's something. See, she thought it was that thing you showed. Yeah, so you're behind the magic 8 ball. Okay, yeah. When you play pool, and I shot a lot of pool over the holidays. Well, I only played one night, but I played a million games. I'm really good. Okay, now, because when I was a kid, I hung out in this pool hall all the time. It cost a nickel a game to play. It's the most grotesque place you've ever been in your life.
I heard those are pretty nasty.
You don't even know this. It's like, I wish I would have taken a picture of this because no one would actually believe it. There were these tin cans, like, you know, if you buy green beans in a big tin can, there's empty tin cans sitting around the wall everywhere. And above each one of them, it was just brown stain. It's where people would spit tobacco, and they'd just spit it towards the can. Didn't even have to hit the can. Just and it hit the wall. And so there's like lumps of tobacco on the wall. It's like the most grotesque thing I've ever seen. Why didn't I take a picture of this?
Because it's gross.
Oh, we didn't have cameras back then. All right. Yeah, it's like, why didn't I break out my smartphone and take a picture? Okay, here we go. We want to know a max, or a min actually, on a closed interval. What does that mean we should do?
0 to 12.
What does that mean we should do? Eyeball. So I've got T, and I'm going to have A. I'm going to have 0, I'm going to have 12. Okay? We know this is 125. And then we got to get the critical values, right? So we say A prime is equal, I'm going to take the derivative of this guy. When I take the derivative of that guy, what do I get? H minus R. And then we set it equal to 0, yes? Yes. And then I get H is equal to R. You plug it into your calculator and find out where they intersect, yes? And your calculator pukes at you 11.318. Right? Now, we already did 12 back in... No, we didn't. No, we didn't. Oh, we did 12. We did 12 in part C. 122.026, yes? Okay? And now I plug 11.38 in place of T. And then my calculator pukes at me 120.738. Wonder which one of those numbers is the min?
That one.
That one. Yes?
Yes.
You guys follow that? Okay? So, on the test next Thursday, what are we guaranteed to have? A future value, and we're going to have one of these problems, and it's going to have a future value in it, and it's also going to have a t-table eyeball. Okay? All right. Now, yes, Woodsy?
So, didn't that on that graph get crossed in 2 places?
Oh, did it?
Yeah, 14.
Yeah, another one was a max, though.
What number was that?
Yeah. But if you plug that in your t-table, it's fine. What was it? 4 point what? 4.790. And when you plug that in, what do you get?
It was 149.
149.408.
That's the way math.
You don't have to include this guy. It's obvious that it's a max. You don't have to put it down. Because it's not a candidate for the max.
Might as well, you never know what he's able to do.
Exactly. You might as well. It doesn't hurt. It takes 2 extra seconds to plug it into your calculator. Okay? Now, today, what we're going to do is we're going to watch a little video. Okay? Now, we're going to watch a video on this because drawing these things on the board is difficult. Okay? Now, when we use the disk method, we had the integral of pi f of x squared dx if we're around an axis. Yes? Okay. Why is that the formula for the disk method? Because it's pi r squared. Is this really pi f of x squared? So this is pi r squared. But what about this dx?
I feel like I know.
That multiplies the third dimension, which is why we get a volume, yes? That's the thickness of this circle, right? Okay? So this guy really what it's doing is it's taking a deal like this, and it's calculating the volume of it, right? Yes? So really what's happening here is when we calculate this volume, I use pi r squared. Why do I use pi r squared? Why not use 1/2 base times height? It's a circle. Why is it a circle? Because I whooped it around and that makes a circle. Yes. Okay? Now, today what we're going to learn is we're going to look at things that are not circles. Okay? So when I look at this guy right here, okay, I have whipped it around, but I could also take a slice of it. After I whip it around and I take a slice of it, what do I get? A cross section, and that cross section is a circle. It's a circle. Can't hear you. 7.2. It's 7.2, day 3. Yeah, we're going to have a test next week over 2 sections, 7.1, 7.2. It's like, you're like, really? I'm like, yeah. Okay? You're like, oh God, this is going to be easy. Yeah, it is going to be easy. It's the second easiest. It's either the easiest test of the year or the second easiest test of the year. Did I tell you guys that last time?
No. Yeah, what's the first easiest?
Chapter 10. The last test of the year.
Oh,
No, the very last chapter we covered. Okay? Let me tell you what happens this semester. I told Monday's class, or Tuesday's 4th period. Okay, this test is either the easiest or the second easiest. Then we cover, in this chapter 7. Okay, then we cover chapter 8. We start BC calculus, right? This is still AB. Okay, we start BC, which is chapter 8. And it's going to be a multiple choice only test, no AP curve. Okay, it's going to be the hardest test of the year. Okay, and then we cover chapter 9. And it's going to be an AP scale, but it's going to be the hardest AP test of the year. And then we take chapter 10, and it's easy. So you get the 2 easiest and the 2 hardest. All in one little package. Yes, sir. Can't hear you.
You said the longest is that easiest thing we do.
Hey, to me, limits are the easiest thing on the planet, but for you guys, chapter 7, chapter 8. Limits are simple, but I just understand. Yes.
If you ask me to look at right now,
What's that?
What's chapter 10 about?
Motion. Yeah, physics. Yeah. It's 2D motion.
Oh, I already know.
Because really all we've had is 1D motion so far. So we're just going to turn it into 2D. Okay, let's watch this video. And then we will do some problems.
Come to the next test. Cody, tap me. Take my test.
He just has like.
Just go in and try to figure it out. I don't
Oh, this is semester.
I made it one of my favorite topics.
Just in the windows.
We have some speakers over here. You see them? Where's the plug? You see that? There you go. You gotta plug these things in somehow. Turn on the volume. You see a plug?
He's like completely across.
I feel like you guys all have
He's just plugging away.
He starts plugging in everything. Taking out
Okay, let's see if this works. You got the volume turned up over there on me now?
It's like all the way.
Okay, let's crank it.
Let's crank it up.
Known cross sections. Alright, so let's first
We had it.
We were so close.
You got signed out.
do a little quick review of what cross sections are. So when you have a 3D object, you can slice the object either vertically or horizontally to get a cross section of the object. So for example, here would be us slicing a pyramid vertically and then horizontally. And you'll notice that here your cross sections are 2D equilateral triangles, and here your cross sections are 2D squares. So now let's see what happens if we put this solid onto a coordinate graph. So bear with me, I am trying to help you visualize this as best as possible because these are not easy to draw by hand. So we will turn the pyramid onto its side and cut it perpendicular to the x-axis infinite times. This will create blank types of cross sections. So here's what this visually would look like. So I took the pyramid and I flipped it onto its side and cut it infinitely number of times vertically. So the perpendicular to the x-axis. And you should notice that your cross sections become squares. Now, if we just look at the base and a single cross section, then we conceive something that looks like this. So this is just the base, okay, and only one cross section. And we can see that the base is made up of two functions, a top function and a bottom function. Because here's the x-axis, and this is the y-axis, and then the 3D is your z-axis. Now the cross-section is perpendicular to the x-axis, so this should start sounding familiar from what we did yesterday. And the cross-section is a very thin rectangular prism, or a square. And it is possible to calculate the volume of a single cross-section. And that's what we're going to be doing. We're going to calculate the volume of a single cross-section. So here is our model. So we want the volume of any geometric shape, which we know is the area of the base times the height. Now the height, in this case, is represented by our change in x, or the thickness of a cross-section. So that part is, since we're cutting it infinitely number of times into infinitely number of cross-sections, this change of x is going to be irrelevant eventually. Now we need the area of the base, which will be some 2D geometric shape. And so what will help you do that is the bird's eye view. So if I was to look at this figure from the top down, I would be seeing something that looks like this. So there's the base of my pyramid, and here is the bottom of the square. So this part right here is this piece on my 3D model. So this gives a 2D perspective of the cross-section. And this resembles finding the area between two curves. So as you notice here, it appears that you have a rectangle between two curves. So, the definition of the volume of a solid with known cross sections. So, first we're going to let S be a solid that lies between x equals A and x equals B if the cross section is known and perpendicular to the x-axis. Then the volume of S is represented by the integral from A to B of the area of the base, or the area of the cross section, times dx, which is your change of x. So that gives you your volume, area of the base times the height of your solid. So, like I said,
You want to write that down? Okay. Muy importante. Okay, you want me to keep going with the video? Okay. Right, you ready? Okay, here we go.
area of the base. And we're gonna,
Write
the
this
second
one down.
part is what if you're going perpendicular to the y-axis. So it's pretty much the same idea. It's just your cross section now in a bird's eye view is gonna have a horizontal rectangle. So this time it's gonna be in terms of y and going from C to D. So
Okay.
possible 2D cross section.
It's the same thing, except you make it. Here, I'll go back. It's the same thing, except you change it instead of perpendicular to the x-axis, perpendicular to the y-axis, and now it's not a sub x, it's a
So
sub
this
y.
time it's going to be inter.
You see? Just all your y's becomes x, all your x's become y's. Okay? All right. We'll start it back up. You ready?
Y and going from C to D. So possible 2D cross sections that you're going to need to know the areas, the area formulas for. So squares, which we know is just side
Write
squared.
this down.
Rectangles, length times width.
You may say, I already know those,
Semicircles.
I don't need that. But
Pi r squared divided by 2. Quarter circles, pi r squared divided by 4. Right isosceles triangles, area equals base squared over 2. And equilateral triangles, which is the square root of 3 base squared all over 4.
and more than likely, you know them all except for that last one. Yes? I mean, really, do you need to write down the formula for the area of a square? Okay, if you do, then write it down. You need to write down the formula for the area of a quarter of a circle? I hope not. But if you think 2 plus 3 is equal to 4,387, you might. Now, the right isosceles triangle, I don't really think you need that one. Yeah, I'll go ahead. The equilateral triangle, that's an important one to know. It occurs on the AP exam a lot. And I always derive that formula because I don't have it memorized.
How do you
Uh-huh.
write?
Huh?
How do you write?
Yeah, 30, make it into a 32.
Is that square root over the whole thing?
Area. What?
Is that square root? No.
Just the square root of 3 and then the b squared. See how the house doesn't stick over the b? Okay? Can we move forward? Yes? Okay, here we go.
And these formulas should all come from your geometry class. And you do need to know these. These will be given to you on the Alright, so let's look at an example.
Okay, we're gonna do one quick example here with her, and then we're gonna do an example together.
The graph
So follow
y
this.
equals 1/2 x minus 1, y equals negative 1/2 x plus 1, x equals 0, and x equals 2. Find the volume of the solid if every cross-section is perpendicular to the x-axis and are squares. So, this actually is our pyramid example. So what I really need in order to integrate is the area of the cross-section is square. You know that the area of the square is sine squared. So one side of this square, as you'll notice, is just this length of this rectangle, or the height of this rectangle. So your top curve minus your bottom curve. So what we were doing yesterday. So I want to integrate that side square. So to figure out what one side length is, I am going to do the top minus bottom. So I need to know which curve is top and which curve is bottom. And since these functions are pretty nice, they're the linears, so your top curve is your negative 1/2 x plus 1. Your bottom curve is 1/2 x minus 1. So now that gives me my side length, top curve minus bottom curve. And then since the area of the squares, you have to square the side length, you have to square this. So this is what I'm going to integrate. So I'm going to go ahead and do some simplifying. So distributing negative, combining like terms. Then I can go ahead and multiply this out to the square. And now I can go ahead and integrate. And then evaluate from 0 to 2. And then simplify. So the volume of that pyramid is 1/3. Alright, why don't you go ahead and see if you can try this one on your
Okay, you don't have to worry about this one.
Alright, so
We're getting ready to go over it.
Okay,
let's go back.
A minus x. And do simplify. Negative.
Mr. Gold, can I have
Finding like
another
terms. Then I can go ahead and multiply this out. Square. And simplify. So the volume of that pyramid is 1/3.
Yes, please.
Okay. Okay. Now, what I've done is I've gotten this worksheet together for you guys, okay? And what I want everybody to look at right now is problem number 2, okay? I like this worksheet because it does give you pictures of what the 3D thing looks like, okay? They will not give you these pictures on the AP exam, so I like to start off with one that does have a picture, okay? So look at problem number 2, okay? So on problem number 2, notice they draw the y-axis this way, and then they draw the x-axis this way, and then they've got this guy right here, okay? Then they got this guy, and then they have this guy. Okay? Something like that. Yes?
Yeah.
And they tell us up in the directions that this is x equal 9 and x equal y squared. There's my x-axis, there's my y-axis. Okay? You can see that they have taken a slice, yes? Is that slice perpendicular to the x-axis or perpendicular to the y-axis? Perpendicular to the x-axis. So that tells me that I'm going to integrate with respect to x. Yes? Are you with me? Okay? Since I'm integrating with respect to x, where does x go to and fro? 0 to 9. Yes. Yes. Notice how she never said anything on the video like, yes. Yes. Well, I'm liable to.
It wasn't like a subtle call. It was like.
Okay.
She went all out.
Now, should I have a pie out front?
No.
Why not? They're squares. There's no pie in a square.
Crazy.
Okay? We need to get it's not a square, it's a rectangle, yes? So I need to get the area of a rectangle that we know is the length times the width, yes? Okay? Now it tells us that the width is what? 2. So now my area is equal to the length times 2, yes? And this is my length right here, yes? Going from right here down to right there is equal to my length. Do you follow that?
Yeah.
Okay? Now, let's figure out how far it is from here to here. How far is that? It's half the length. But give it to me another way. What is it? How tall is that? How tall is this? It's y tall, right? It's y, yes? Whatever y is. Tell me what y is here. Y equals the square root of x. Yes? Right?
We have to do plus or minus.
Nah. Because what I just drew is just y. So this is actually the square root of x. This is the negative square root of x down here, right? Yes? Okay? So now, tell me how long L is. It's 2y, or it's equal to 2 square roots of x, since that's what y is. Yes? Do you follow me? Yes? Okay? So I come up here, and what is the area of this rectangle then if I plug in for L? 4 square roots of x. Yes? So, I write 4 square roots of x there. Do you see why this gives us the volume? Because what am I adding up here? I'm adding up an infinite number of areas of rectangles. When you add up an infinite number of rectangles, it gives you the volume of this weird-looking thing. Okay? Everybody down with that?
Yeah.
Yes.
How'd you get the 0 to 9?
It's given up in the top of the problem.
Yeah, so it's between 0 and 9. Because it says.
Look up in the top. It says, let R be the region bounded by the graph of x equals y squared and x equals 9. Are you not saying that?
Unless it specifies otherwise.
0 to 9.
There's the smallest x equals 0. Okay?
Like that.
All right, everybody down with this? Okay, let's do this problem here real quick. Focus, focus, focus. We're running out of time. So I got 4. What happens when I integrate the square root of x? I get x to the 3/2 over 3/2, which is 2/3. So I get 8/3, and then from 0 to 9. See, that's the way all math teachers call. I get 8/3, and I get 9 to the 3/2 minus 0 to the 3/2. What's 9 to the 3/2? 8 times 27 over 3. Whole thing's 72. But it'd be calculator active, right? But you use a calculator when you need to. Okay?
Yeah, but the calculator.
What's that?
If the calculator can do it faster, then it can save us time.
Right, but it can't even do it faster than me.
Than you. Than me.
Then use a calculator. Okay? Now, let's turn the page. Turn the page. Okay? Now we no longer have pictures. Okay?
Whoa.
Wait a minute. Wait a minute. Okay? Let's look at one of these problems on the back. Okay? And not number 11, because I want to save that one for you. Okay? Numero 14. Okay? No, number 16. Okay? I want to do one that's perpendicular to the y-axis, so we can see how that works. Okay? So, it says a solid has as its base the region in the xy plane bounded by the graphs of x squared is equal to 16y and y is equal to 2. Well, this thing right here is y is equal to x squared over 16, which is a parabola, right? And there's y equal 2. Are you with me? Yes? Now it says, if every cross-section perpendicular to the y-axis is a semicircle. So when I take a slice here, I get a semicircle. I'm taking a slice, and this is a semicircle. You have to use your mind's eye and realize that this thing is sticking out of the board towards you.
Okay, so it's coming this way.
It's coming this way, straight towards you. This thing right here. There's no way I can draw it otherwise. Okay? And you're like, well, I don't see that. You either got to see it or you got to be able to draw it yourself. I'm no artist. Okay? If you're an artist, then draw it better than me. Okay? So,
Wait, on problem 16, it says if they're a rectangle.
Yeah, it's not a semicircle. It's not a semicircle.
Yeah, it does.
Nobody else was saying.
okay? That's what it looked like if it was a circle. But on 16, it says every cross-section by a plane perpendicular to the y-axis is a rectangle. So it's another rectangle. Crap. Yes?
That's not too bad.
That's very, wow.
Okay? You have to realize that that's sticking out of the board.
That's really good.
Okay? Now, what we need to do is we need to figure out the area of this rectangle. We know it's the length times the width. Well, they tell us that the length, the height or the length is equal to twice of what the width is. Yes? Okay? Let's call this right here the width. My picture's about to get ugly. There's my width. How long is it from here to here? Well, it's half the width, isn't it?
Yes,
But it's x, right? What's x equal to? Square root of 16y, which we all know is 4 square roots of y. Okay? A lot of us don't like to simplify the square root of 16. They like to leave the square root of 16 on the paper, not me. Okay? That's what x is. So, how long is my width? 8 square roots of y. Yes? Right? Why is it 8 square roots of y? Well, you got 4 square roots of y there and 4 square roots of y there, and put them together, you get 8 square roots of y. Yes. Yeah. Yeah. Okay? Now, so for me to get the volume, I'm going to integrate from where to where? 0 to 2 dy. And what am I going to integrate? 8 square roots of y. The area. The area. Oh, my bad, my bad. That's not the area. What is the area? Area is equal to L times W. What did we say W was? 8 square roots of Y. And what is L? It's 2 of these, right? So how much is it? 16 square roots of Y. So it's how? What's 16 times 8? How much? 8. 128? 128 Y. Yes? Are you with me? So I get 128 Y squared over 2 from 0 to 2. 2 goes into 128, 64 times 2 squared is 4. Anybody know what 4 times 64 is? 256. But it'll be calculator active. Okay? Alright. Now, whilst you guys are working on your quizzes, I'm going to pass out the study guide for the test. Okay?
Do we have an online one too?
Yes, that's a good idea.